Okay, I think it will right now. Go ahead and tell me what it is.
Okay, the problem is 28.
Oh my goodness. It still isn't writing. Okay, just a second. Okay, here we go. Okay, factor 28.
X to the 6th power plus 20x to the 4th power plus 4x to the 3rd.
Okay. All right, so whenever we factor, the first thing that we want to do is always look for a GCF that we can take out. So let's look at the number parts first. So what's the largest number that we'll divide into 28, 20, and 4?
4.
Okay. And then what about our variables?
X to the 3rd.
Yeah. Okay, so when we do that, we should be left with 7x to the 3rd plus 5x and then plus 1, because 4x to the 3rd divided by 4x to the 3rd is 1. All right.
And this is where I just didn't know what to do from here.
Okay. So we're going to kind of forget about that 4x to the 3rd for a minute. It is part of our answer, so we don't want to forget about it completely. But this is the part that we're working on trying to factor, right?
Right.
And so when we're looking at this, you look and say, okay, and this was for sure. Okay, yeah.
Yeah, I wrote it down twice.
Okay.
I actually sent you a message with it in it, so.
Yeah. I mean, because looking at this, what you would do is say, okay, 7 times 1 is 7. So you're thinking what multiplies to be 7 that adds to be 5, right?
Yeah.
And there's not anything. So that means we can't factor it any further. And this would be done right there.
But would you say it's prime? Because I tried to put that answer in and it didn't take it.
No, it's not prime because we could factor out a greatest common factor. So we still could factor it.
Oh, well, that's where I went wrong.
Yeah.
I think that's what I did with the other one, too.
Yeah, if it would have started off with just this, you know, and you didn't have anything more, then yeah, then the answer to that would be prime. But yeah, but because we could factor out something, we could do some kind of factoring, then we just write that whole thing down as the answer.
Thank you.
You bet. All right, good question. Anything else?
I'm working on one right now that I can't figure out either.
Okay, do you want to look at it? Oh, yes.
Yeah, it is 2x squared minus 20x plus 48.
Okay, so what are we going to do first?
Greatest common factor, which is 2.
Okay, so 2 comes out, leaving x squared minus 10x and plus 24. Okay, and then what are we thinking from here?
Well, I was going to try to do you have x times 24 and then do multiples of 4. And I was thinking you would want to do the negative 12 and a positive 2 to get your 10x. Are you following?
Okay, yeah, so we're thinking what multiplies to be 24 that adds to be negative 10.
That's what I was thinking.
Okay, so if we think about like all of the things that multiply there, right, I'm just going to list them all out. So 1 times 24, and I'm going to just work organized, right? And so then 2 times 12, 3 times 8, and 4 times 6. And then we need to think about, is there a way that we could add or subtract these numbers together to end up with a negative 10?
I just chose the wrong one. I chose 2 and 12 when I should have chose 4 and 6.
Yeah, so 4 and 6, if we make those both negative, right, negative 4 times negative 6 gives me a positive 24, negative 4 plus negative 6 gives me that negative 10.
You answered my question already.
Okay. Yep, so then, I mean, that would just be the answer there, x minus 4, or 2 on the outside, and then x minus 4 times x minus 6. Okay, and the reason we can go, you know, like up here, our leading coefficient wasn't 1, so we can't go straight to the factoring like this, but since this leading coefficient was 1, that's why we can go to this. Because if this would have, if there was something we could think of, and I'll do one, I have one planned, you know, to look at, so you can see when, you know, you can go straight to the, I call it hippo butts because it's just like, what do we call this? Just because like, oh, it just kind of looks like you're looking at the rear end of a hippo. So yeah, so I just call that hippo butts, and so we go straight to hippo butts if you, you know, if the leading coefficient is 1. So, all right.
Thank you.
Yeah, you bet. Okay, so let's get started into some stuff today. Remember that, you know, formulas and stuff are things that you need to make sure that you have memorized, and you might need to know some of the formulas from last time, right? So you might need to make sure that you remember the slope formula, right, is m equals y2 minus y1 over x2 minus x1. All right, so that's the slope formula you need to have memorized. And then there's also point slope formula, and this helps us write equations of lines. And so it says y minus y1 equals m times x minus x1. So definitely make sure that you have those, you know, those memorized for the exam. Other than that, make sure, I guess, that you know area is length times width, and with perimeter, you just add all sides. All right, other things I guess that would be good to know that we talked about, and we'll do an example like this to start off with. So remember that some of the stuff from the past tests can show up again, and so you want to make sure that you're, you know, keeping some of those things in mind. I'm trying to look back to where I had this. Okay, so variation problems. Right, so like if we're doing direct variation, you need to have memorized that that is y equals k times x, and then inverse variation is y equals k over x. Right. Okay, so let's look at an example like that. For this first one, first problem one here, so I gotta find where problem went. Okay, so just gonna number these, I guess. Y varies directly as x if x equals 7 and y equals 35. Why this is not. It's like, keeps moving around for some reason. Okay, find y when x equals 3. Okay, so starting off on this, which one of those two variation formulas do we want to use, and why?
You'll do the direct.
Yeah, because it says it varies directly. All right, so that's what's giving it to us. So we want to look at the y equals k times x, and we're just going to put in what they gave us. All right, so so this first sentence is just telling us which formula we need to use. The second one is what we're going to do next. Just put those two numbers in. So put 35 in place of y. We don't know what k is. That's what we're solving for. And x is 7. And then to get k by itself, to solve for it, we'll divide both sides by 7. So that means that k equals 35 divided by 7, which is 5. Okay, and then we're going to use that, because we haven't found what they wanted us to find yet, find y when x equals 3. So I'm going back to that same direct variation problem and putting in what I know now. So I don't know what y is, that's what I'm trying to find. I just found that k equals 5, so that's going to go here. And then in place of my x, I said x is 3, so 5 times 3. So y equals 15, and that would be your answer. Okay, so you're going to be kind of sunk if you don't have these variation formulas memorized. So make sure that you have those memorized on this as well. Okay. All right, a couple of other things maybe from past exams that should make sure that you know how to do. There was quite a few people that missed like the mixture problem on the last exam, and so where you're solving systems of equations, so something like that would be good. And also writing equations of lines could be something that shows up. And then so let's look at maybe a few of those. So if I said let's look at the story problem again, like I was talking about, because it just seems like most people struggle with knowing how to set it up. And so once you have that, it's not so bad. Okay, so a store owner wants to develop a new snack mix by mixing chocolate and trail mix. Okay, so I'm just going to kind of abbreviate here. Mix chocolate and trail mix. Okay, how many pounds of chocolate costing, I'm struggling writing today. My handwriting is usually a lot better than this. Okay, $15.20 per pound. Let's see, so how many pounds of that should be mixed with trail mix costing $3.10 per pound. Oops, the same like I had over there. To create a 28-pound mixture, costing $9.45 per pound. Okay, so I did this one last time on the review, and so I just want to make sure that everybody is feeling really comfortable. And I usually set this up in a chart. You don't have to set it up in chart format, but it helps me to keep my information a little bit more organized, so that's why I do it that way. So along the top, I put the things, the things that I am mixing together. So I'm mixing chocolate and trail mix, and then the total would be those two things combined. And then down the side, I need to remember the labels that are in here. So I'm dealing with pounds, and I'm dealing with money. So the price, and then the total. All right, and then I'm just going to fill in what I know. And I guess before I do that, I want to identify what my variables are. So I'm going to choose the variables X, and X is going to be pounds of chocolate, and Y is going to be pounds of trail mix. All right, so I just like to identify my variables over here, which one's which, so that when I get done I know what I was dealing with. Okay, so I don't know how many pounds of chocolate or how many pounds of trail mix. That's what I'm trying to find. So those are going to be my X and my Y. But I do know that I want a total of 28 pounds together. So 28 is going to go there. Then let's go and put the price of everything. So chocolate, right, costs $15.20 per pound. The trail mix is $3.10. And then our total here, well, sorry, the price of just that so far is just $9.45, yeah, per pound. Okay, and then to get our last equation, so this is our first equation, we already have it. And then our last equation, we're going to multiply the first and second rows together. So 15.2x and then 3.1y. And now here, to get this number, I need to multiply 28 and $9.45, which I think is $264.60. Okay, so I multiplied those together, and that's usually where some people get stuck. Remembering that we got to multiply those together. And so then I have my second equation, right, is this. So I'll put it over here. So I'm going to have 15.2x plus 3.1y equals 264.6. And now we just need to decide whether I want to use the substitution or elimination method to solve it. And either one is perfectly fine. It's just kind of what you feel more comfortable with on it. So I don't know. Does anybody have a preference of whether we do substitution or elimination?
I like substitution.
Okay, so let's use this top formula then, because it's easier to get one of the variables by itself. So say that I wanted to get y by itself, then I'd need to minus that x over. So that means my new equation here is going to be y equals 28 minus x. And then I can take that, oops, don't need to do that whole part, that 28 minus x, and I'm going to put it in place of y right here. Okay. So I'll have 15.2x plus 3.1 times all of that stuff I circled in green there. So 28 minus x, and then equals 264.6. Next, we need to distribute that 3.1 through to everybody. So let's see, so 3.1 times 28 Am I doing that right? Yeah, so is that, let's see, just gonna make sure I have this. And if you guys get it, you can also blurt it out. So 28 times 3.1.
I got 86.8.
Okay, 86.8. And then 3.1 times negative x is just negative 3.1x. And still equals 264.6. All right, now we need to get our x's together. So 15.2 minus 3.1 is going to give us 12.1x. And then I still have this 86.8 equals the 264.6, and now we need to subtract the 86.8 over. Wow, I'm running out of room here, sorry about that. Okay, so I've got 12.1x, and when I subtract those, I come up with 77.8. Is that what you guys came up with? Doing that right. And then we'll divide by 12.1. So then 177.8 divided by 12.1 is going to give us 14.694, blah, 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 blah. And it'll tell you where to round to. So if it just wants you to round to the nearest pound, all right, which is going to be the easiest in this case, then that 6, I lost my cursor here, okay, then that 6 is big enough to round that up. So this is going to round up to 15 pounds. So we've got 15 pounds of our X, which we said is chocolate, so 15 pounds of chocolate. So that's one of our answer. How do we find how much trail mix then?
You just subtract the 15 from the 28.
Yeah. So going back here, we did this y equals 28 minus x. So if you kind of put it in there, you know, maybe 28 minus 15. And what does that give us? £13 of trail mix. Okay, any questions on that I can clarify better for you there? All right, so like I said, make sure you go back over, look over kind of like those inequality things, with the and or statements, and also writing equations of lines and having those memorized too, those formulas that you need for writing equations of lines. Okay, let's get into some of the stuff that is going to, that we want to look at from, where was that here? From Module 5 and Module 6. Let's see. Okay, so next question. So in Module 5, you talked a lot about the properties of exponents. And although you don't need to have them memorized, it's not like I'm going to say, like write these out. You do need to know, like what's happening with them. So meaning when you have some exponents, right, that are connected by multiplication, then you add those exponents together. If they're connected by division, you subtract them, and so on. So you just need to keep those in mind, and we'll go through some of those on this question here. Okay, so it says simplify. And we've got 3x to the negative 4 power y squared over, let's see, where's that here, x to the 5th y to the 5th, and z to the 5th. And then this is all raised to the -3 power. Okay, now I'm going to show you the way I would do it, but there are so many right ways that you can do this. So if you think about doing it in a different way, that's totally fine. Work it through, the way that you're thinking, and then see if you come up with the same thing that I get in the end, because you don't have to work it in the same way that I'm working this one. Okay, but for me, I like to get rid of that negative exponent on the outside first, which means I need to flip this whole fraction. So whatever is on the top goes to the bottom, and whatever is on the bottom is going to go to the top. Okay, so I'm going to have my 3x to the -4th, right, just how it looks here, that stays exactly like that. Okay, I'm just flipping it because of that negative out there. So 3x to the -4, y squared, and then on the top, I've got the x to the 5th, y to the 5th, z to the 5th. And now everything is raised to the 3rd power. Okay, and again, I just don't like having negative exponents. So I'm going to take this x to the -4th power. It's unhappy down here, so I'm going to flip it upstairs where it's going to be happy. All right, so then we'll have all positive exponents. So when I do that, then I get x to the 5th, y to the 5th, z to the 5th, and then I have also x to the 4th when I flip that up there. And then on the bottom, I have 3y squared. And again, this is still all raised to the 3rd power. And some of you may have decided to distribute that through right away first. And like I said, that's totally fine. That is another way you can do it. And I'm not going to even do it yet. I want to get all of my stuff together inside so there's less that I have to distribute through. But if you do it differently, you still can get to the right answer. All right, so I can see that I've got these x's I need to combine together. So those are connected by multiplication. So that means I need to add those exponents. So I've got x to the 9th. Right, when I add those. And then I can see I also have these y's that I need to combine together. And these are connected by division, so that means I need to subtract the exponents. So y to the 5th divided by y to the 2nd, I need to do 5 minus 2, which is 3. So I get y to the 3rd on the top. And then I still have that z to the 5th. Don't have anything to combine with it, but it's still there. I need to leave it there, and I've got a 3 kind of by itself on the bottom. And it's still all raised to the 3rd power. Okay, and now I'll distribute that power of 3 to everybody. It's just the way I choose to do it. So when I do this, when it's a power raised to a power, I multiply those. So it's going to be x to the 9 times 3, which is 27. Y to the 3 times 3, which is 9, y to the 9th, and then z to the 5 times 3, which is 15. And then I still need to make sure I give this guy a power of 3 too. 3 to the 3rd power, okay, and 3 to the 3rd power, 3 times 3 times 3 is going to give us 27. So we could just write that like that as 27. Okay. And then that would be your answer.
Do you remember something?
Yeah.
Okay, so in the past, when we've had exponents, like even with your green x to the 5th and x to the 4th, because they were multiplied, you added them together.
Yes.
So, but because this 3 below it and the next problem down is raising the whole problem to the power, is that why we multiply?
That is exactly why we multiply. Yep, because this is like saying x to the 9th all raised to the 3rd power. It's not saying x to the 9th times x to the 3rd.
Got it. Thank you.
Yeah, good question. Okay. All right, so make sure you just know how to use properties of exponents. I tried to do one that involves a lot of different things just so we could, talk about all those different properties of exponents. But make sure you practice up more of those problems. Also, make sure you know how to write things in scientific notation. And really, the reason why we do this is because science classes has said, they want students coming in knowing how to write things in scientific notation. And so, let's look at this one. If I have 3.9 times 10 to the 32 power, and I'm multiplying that by 4.4 times 10 to the negative 40th power. Okay, then to do this, I need to, this is connected by multiplication. So let's just start off by taking those whole numbers, those numbers out in front, those decimal numbers out in front, and multiplying those together. So 3.9 times 4.4. And write out all the digits that there are there. And it should be 1.716. Okay, and then we need to look at this 10 to the power, right? So really on this, let me just write it out over here. If I have 10 to the 32 times 10 to the negative 40, right?
Can I ask another question?
Yeah.
I'm so sorry.
You're good.
So why are we not multiplying them? The 3.9 and the 4.4.
I thought we did.
How did you get the one?
Oh, sorry. It shouldn't be. I put the decimal in the wrong place. Is that what you mean?
Okay, so it's 17.60.
Yes, it is.
I'm so sorry.
Nope, that's fine. That was my mistake. I put that decimal in the wrong place. Okay, so 17.16. All right, and then these other two, right, since it's connected by multiply, then we can add those exponents together because the bases are the same. Well, we have one positive and one negative, so we're really going to subtract that. So that's really going to be 10, right, because that's our base. 32 minus 40 is negative 8. Okay, but right now, this is not written in scientific notation like it is, because this number is 17. And in order to be written in scientific notation, that number out in front needs to be bigger than 1, but smaller than 10. Sorry, bigger, well, I guess really bigger than 0, smaller than 10. Okay, and so now we've got to figure out, okay, how do we need to move this? Well, I know that I need to move this decimal place, 1 back, so that I can get it to be 1.716. And that will now be in scientific notation, where when it's 17.16, it isn't. All right, but if I move this decimal over here, then it changes my exponent on this. Okay, and so by moving it 1 to the left, I'm really adding 1 to this. So negative 8 plus 1 is going to give me negative 7. And if you're not sure, you can write it out, like take that, 17, let's see, I can do it like this, 17.16, right? And you write it out as, to the negative 8 power. Well, that's going to be 1, 2, 3, 4, 5, 6, 7, 8, right? But then, we got to figure out, okay, we want it really to be there. Well, how many places have we moved? 1, 2, 3, 4, 5, 6, and then that last one is 7. So that's why it's to the negative 7 power. Because that would be like the number written out without scientific notation, 0.0000001716, right? But then we can see, oh yeah, it's going to be 7 places, not 8, so negative 7. Okay, so just be careful on that. Make sure you know whether you're moving it to the left or to the right. If you had to move it to the left, sorry, did I say that wrong? When you move it to the left, I can't remember what I said now, so let me say it again. When you move it to the left, you add 1. If you had to move it to the right one place, you'd subtract 1. Okay, so that's kind of how you can remember that, or just write out the whole big number if you'd rather and check it that way. That's perfectly fine with me. Okay, let's look at subtracting some polynomials also, because there is always something on here that tends to be something that students might kind of mess up here. So if I have 6x to the 5th minus 5x squared minus 6x, so I have this whole polynomial, and I want to subtract off 4x to the 5th minus 9x squared plus 8. Okay, well, really what I'm doing here, when I'm subtracting all of that, this is really like I'm taking and distributing a -1 through to everybody. Right? And when I do that, what happens really here is it just changes the sign. So this is a negative, this is a positive, and this is a negative. And then I usually just like to write them down underneath their like terms, just to make sure I'm adding the right things together. So I'm going to put my -4x to the 5th under my other x to the 5th, and then my positive 9x squared under that. But notice that this is a -8, not a -8x. So it doesn't go under the x, it's going to go over here, -8. And then I can combine all of these together. So 6 minus 4 is 2. 2x to the 5th, -5 plus 9 is positive 4x squared. Bring down that -6x, nothing to combine with it, and also that -8. And then that will be your answer. Okay. And again, make sure you're just showing as much work as possible on the exam, because I will give partial credit, and if there's no work shown, sometimes I have to mark the whole question wrong. So please, please, please make sure that you are showing work, and you need to show work right on the exam. If they give you scratch paper, they're going to take it and not give it back to me. So you need to write everything on the exam that you want me to correct. Okay, let's look at a multiplication one also. So if I was asked to multiply something like 2a plus 5b times 2a minus 7b. All right, so this you can, maybe you've, use the acronym FOIL to help you remember how to do this. And this stands for first, outside, inside, and last. So it's just a little way to help you remember and make sure that you're multiplying everything together the right way. So if I multiply the first terms of each of these binomials together, I'll be doing 2a times 2a. Well, 2a times 2a is 4a squared, right? Because I have an a and another a. And I'm adding those exponents together, so that's why I get that a squared. Okay, then I'm going to take that 2a and multiply it by the -7b, right, which is my outside term. So 2a times -7b is -14ab. All right, then let's do our inside terms. Take 5b times it by 2a. It's going to give me positive 10ab. And then my last one here, let's multiply 5b by -7b, which is going to give me -35b squared. And then I just need to add the like terms together, and I can see in the middle these are both AB terms, so those can go together, and that's the only thing that can. So I'll have 4a squared. Combine these together. Negative 14 plus 10 is negative 4ab, and then negative 35b squared. And then you'll be done. That is your answer. Questions on that? Okay, let's get into some factoring. I want to make sure that we spend plenty of time on that, because that's where the meat of what we were doing in this these two modules is at. Like this is probably one of the most important things that you learn this semester, is all about how to do factoring. Okay, so let's start off by just factoring out a greatest common factor. So sometimes it will just say factor. The directions might say factor out the greatest common factor, but either way, we've got to make sure that we are factoring things completely. So negative 35 x to the 4th y to the 5th minus 15 x to the 3rd y to the 6th, and then minus 5x squared y squared. Oh, sorry, y cubed. Read my writing there. Okay, so we're going to look for a GCF, and we kind of did some of this at the beginning of it, where we're looking to see, okay, let's look at just the numbers. Okay, so what is the largest number that will divide into all three of those numbers?
Negative 5x squared y cubed.
Okay, so if we're looking at just the numbers, yeah, it's going to be the 5. And why did you say negative 5? Because that's correct. We want to take out that negative.
Your leading coefficient is a negative, so you always want to take out the...
Yep. Exactly, right? We want to take that out if it's negative. Okay, and then if the x's, right, we're looking for the smallest exponent on these. So if the x's, x squared is the smallest exponent, and with our y's, we got y to the 5th, y to the 6th, and y to the 3rd. So y to the 3rd comes out. And then really what we're doing here is we're dividing each of these terms by that GCF. And if it's easier for you to kind of think through this by writing these underneath and then dividing them out, then that's perfectly fine to do, right? That's what we're doing. So this, when we divide it out, that's going to give us the leftovers, what goes inside. So I can see here, right, negative 5 divides into negative 35 7 times. My x's, I've got 4 on the top and 2 on the bottom, so I subtract those and get x squared. And here I subtract the y's as well. 5 minus 3 is 2, so y squared. Okay, now let's move on to that second one. Negative 5 divides into negative 15, positive 3 times, so plus 3. And then with my x's, I just have 1 x left. With my y's, I still have y to the 3rd. All right, remember I'm subtracting those exponents. Okay, and then on the last term, watch this one. So negative 5 divided by negative 5 is 1. Right? X squared divided by x squared is 1. And y cubed divided by y cubed is 1. So I've got 1 times 1 times 1, which is 1, a positive 1. You've got to make sure that you put that part down. That tends to be something students leave off, is forget that that's 1, because you're dividing everything out, but when anything divided by itself is 1, not 0. Okay? And then that's all we can do with that. So that is factored completely. Okay. Now let me just say, on the factoring problems, on almost every question, it says if it can't be factored, then state that it's prime. don't put prime on every question, okay? I want to see that you can factor. There might be one question on the exam that is prime, but that would be it, okay? I would not make a bunch of them prime because that doesn't show me that you know how to do the different types of factoring. So if you're coming up with prime on every single one, then look at what you're doing and, see if you can figure out where your mistake is, because it's definitely not going to be like that. Okay, let's factor something like this. So if I have w cubed plus 6w squared minus 3w minus 18. Okay, so this is a 4-term polynomial. And when I have 4-term polynomials, I want to do factor by grouping, right? Which means I'm going to split this so I have two, I have a pair of terms in front and then a pair in the back, all right? So I'm splitting it exactly in half. And then I'm finding the GCF of the first terms and then the GCF of the second terms. Now, you should always, always, always look to see if there is a GCF that can come out of everything. And sometimes I forget to, say that I'm looking for that, because I always look for that before I do anything else, but sometimes I forget to say it when I'm explaining things. So I want to make sure that's clear. You always want to look for that. And there isn't on this one. So now let's just start by looking at these first two terms. It looks like w squared is what can come out. Right, factor out, and I'm left with w plus 6. On this one, negative 3w and negative 18. Since this is a negative right there, we want to factor that negative out like we did before. So we're going to factor out a negative 3, leaving w plus 6. All right, and then to do the factor by grouping, these guys have to be the same. If you don't come up with something the same there, then you did something wrong, because those will be on the exam. They'll come out nicely like that for you. So our common factor is that w plus 6, so it comes out, and then the stuff is our leftovers that goes in the other parentheses, so w squared minus 3. And all of this together is your answer. Okay. Questions there? Okay, let's take a look at this. And sometimes it will say something like factor completely. And sometimes when it's using that word completely, it's like trying to make you think about, is there a GCF that needs to be taken out first? Sometimes it says it and there isn't a GCF, but oftentimes those instructions happen when there's a GCF that needs to be taken out. So use that to your advantage and just to help you remember, oh, did I take out a GCF? Okay, so in this one, x to the third plus 3x squared minus 40x. Okay, so is there a greatest common factor, all three of those terms?
X.
Yeah, x is the only thing that can come out, all right, which will leave us x squared plus 3x minus 40. Okay, now our leading coefficient is 1 here, so that means I can go straight to hippobutts, right? So those parentheses. And so I'm thinking what multiplies to be negative 40, that adds to be 3. All right, and if you're not sure, just list out all the possibilities that are there and work organized. 1 times 40, 2 times 20, 3 doesn't divide in, 4 times 10, 5 times 8, and that is it. All right, so now which one of those would add or subtract to give us 3? Well, it would be the 5 and the 8, but I need the 5 to be negative and the 8 to be positive to add to be that, right? Negative 5 plus 8 gives me a positive 3. So I have x minus 5 in one of the parentheses and x plus 8 in the other parenthesis. And then make sure you don't forget that x out in front. It's still part of your answer. Okay. And remember with factoring, you can always, like if you have time at the end of the exam, go back and FOIL these things back out, like multiply it all back together and see if you come back with what you started with, because there's no reason to miss any of these. You can always multiply them back out to see if that worked out and came up with what you started with. All right, let's do a few more factoring here. Let's do some where our leading coefficient is not 1. So if I have 2y squared minus 19y plus 35. Okay, so on this one, right, our leading coefficient isn't 1. Up here it was a 1, so I could go straight to hippobutts. But now I've got a 2 there. So what I've got to do on this is something called the AC method, where I'm going to multiply my first term, just underline them here, with my last term. So 2 times 35 is 70. So now, instead of saying what multiplies to be 35, no, I have to make sure I include this 2 here. So I multiply those together, get 70. So what multiplies to be 70, that adds to be negative 19. And then again, just list out all the possibilities if you need to on this. All right, so it's 71 times 70, work organized. 2 times 35. 3 doesn't divide in, 4 doesn't divide in, 5 divides in 14 times, 5 times 14, and then 6 doesn't, 7 times 10, and then 8 and 9 don't divide in. So these are all of my possibilities here. So now that I've got them all listed, I can say, okay, which one of these could add or subtract to give me negative 19? Well, it looks like it's going to be 5 and 14, and both of those would need to be negative. Okay, now I want to caution you here, because this is a mistake that I see a lot of times on the test. People will put the answer as x minus 5 times x minus 14. If you FOIL this back out, are you going to get this? No way, right? Look at, how can you even get that 2 at the front here? Oh, it should have been y, not x. But even if those are y's, you're still not going to get back there, right? And so be really careful about that, right? On this one, we can't go straight to hippobutts. We've got to write down the 4-term polynomial. So I keep that first term the same, 2y squared. And then my middle term is going to split out into 2 other things, and that's what I found here, my winning combination. So inside here I'm going to have negative 5y and negative 14y. All right, that's what I found my winning combination to be, so I need to put those 2 in the middle there. And if I add those together, I do get negative 19y. Right? All right, and then plus 35. I bring that last term down. Now it's just a factor by grouping. I have 4 terms. I'm going to split them in half here and then factor out the greatest common factor. On this, only a y can come out. It's going to leave me 2y minus 5. And over here, it looks like a negative 7 can come out, which is going to leave me 2y minus 5. All right, I can see I've got the same thing inside the parentheses there. That becomes my first factor because I'm factoring out that greatest common factor of 2y minus 5. And then these guys go in the other parenthesis as my leftovers. So all of this,
I have a quick
is your
question.
answer. Yes.
So what if you were to swap the place of the 5 and the 14?
Yeah, it actually doesn't matter. So 2y squared minus 14y minus 5y plus 35. So let's see what happens here. All right, so now I get a 2y that can come out, leaving y minus 7. And here, a negative 5 comes out, leaving a y minus 7. So this time, and the thing that is different is our greatest common factor this time is y minus 7, and then my leftovers are 2y minus 5. And this is multiplication, so it doesn't matter which term we write first and which factor we write first and which factor we write second, right? It's commutative, so either of these answers would be correct. Good question. I'm glad you asked that. Okay, so it won't matter which way you put those inside. You still will be able to do that. If you're struggling, like factoring it one way, then try flipping those in the middle and see if that helps you to find a greatest common factor easier. All right, let's see. I want to do just maybe just a few more here. Let's do one like this. Probably go until about a quarter after, just so you guys know. All right, so if I'm asked to factor 9x squared minus 25y squared. Okay, so this is called a difference of squares. I have a binomial, right? I have 2 terms this time instead of 3 terms like I have had. But I notice that 9 is a perfect square and 25 is a perfect square. Okay? And so if you remember things about square roots, you're going to be talking about them more next chapter, but a lot of times people remember something about them from before. So if you kind of took the square root of that whole thing, that's going to give you this 3x. And if I took the square root, I'm going to do this in a different color, of that, not with the negative in there, just this part, right? Then you're going to get square root of 25 is 5, square root of y squared is y, and then I need that to be negative inside there. Well, yeah. And so when I'm writing this down, so when I'm doing a difference of squares, one of my factors is going to be like this, right? And then my other one is going to be the same 3x and 5y, but now it needs to be connected by addition. Because what happens on this is our middle terms end up canceling each other out. Do you see negative 5y times 3x is negative 15y? And then if I do 3x times 5y, that gives me positive 15y. And so those zero out, which is why we don't have a middle term up here. So that happens when we have one, exactly the same thing. One's connected by subtract, the other is connected by add. Okay, so just kind of, keep that in mind. That's just a little, maybe kind of a little shortcut to help you get there. All right, we need to look at some, and remember, like there could be a question on there that is prime, but if there is one that, won't factor at all, right? If you can factor out a greatest common factor, that's not prime. If it can't factor at all, then you'd say it's prime. But if there is one on the exam, there would only be one. So don't get overzealous with those things. Okay? All right. Let's take a look here. Let's do, oops, okay, so x squared minus 9x plus 8 equals negative 10. Okay, so you're asked to solve this, but notice that this isn't equal to 0 yet. So it's got to be equal to 0 before I can try and do any factoring. So first thing I want to do is add my 10 over so that I can get 0 on the right side. So I've got x squared minus 9x plus 18 equals 0. Now I need to factor this. Okay, now notice that the directions on this say solve, not just factor. Okay, be careful on some of the factor questions. Sometimes people try and solve those, like, you know, somehow just pull out of the air, put this equal to 0 and solve. Well, you can't do that. If there's not an equation, you know, an equal sign starting off in it, you can't just put one in there. Okay, so this one has one in there starting off. If I factor this, what times what is 18? That adds to be negative 9. Well, 6 and 3 does, and if they're both negative, it'll add up to be a negative 9. All right, and then the zero, in the zero product property says we're going to set each of these equal to 0 and solve. So x minus 6 equals 0 and x minus 3 equals 0. So here I need to add the 6 over, x equals 6. Here I'll add the 3 over, so x equals 3. Okay, and I am expecting 2 answers on this, and you'll get more into this in 1010 and 1050, but you see how this is like my highest exponent in that original question is a square? That's telling me how many possible solutions I could have. So it's telling me I'm going to have 2 solutions here. So that's a good way. If it was x to the third, then I would expect to have 3 solutions there. Okay. All right, let's look at just one more problem, I think, with a little story problem here. Let's see if I can move this up. Okay, so this one says the width of a rectangle is 2 meters less than the length. If the area is 120 square meters, find the length and width. Oops, oh my gosh. I'm struggling. Let's see if I can spell this right now. Find the length. Oh my gosh. What's happening with my pen? Okay, length and width. Okay, so let's draw a picture, because already in my mind I'm trying to visualize what this is saying. So whenever that happens, I just like to draw a picture of what's going on here. So I've got a rectangle. I know that. Okay, now I'm going to call this the width of my rectangle and this longer side the length. It doesn't matter which one I call which, but just as long as we're seeing this, right? So the width of the rectangle is 2 meters less than the length. Okay, so it's giving me stuff about, well, how this is ending. Let me say it this way. So it's saying 2 meters less than the length. So I don't know what the length is. So that's usually the one that I choose for my variable. I don't know what the length is. Okay, but I know there's a relationship to the width. The width is 2 meters less than that, whatever that is. So I don't know what the length is, but the width is going to be 2 meters less than that. Okay, is everybody okay with that? You could actually put like L plus 2 and then L over there. It still would work out, but I think just the way this is saying it, that less than means subtract. So I think that's how most people will write it. And we know our area is 120. Okay, so the formula for area of a rectangle is length times width. All right, so my area is 120. My length is L, and my width is L minus 2. And so now I'm just trying to solve this for L. Now remember up here how I said we had to have everything over on one side and put equal to 0 in order to solve that. Same thing is true here, but we also have some distributing that we've got to do, right? So I'm going to distribute this through. So I've got 120 equals L times L is L squared, L times negative 2 is negative 2L. And now I want to subtract the 120 over so that I can get 0 on one side. Right? So I've got 0 now equals L squared minus 2L minus 120. And this is what I need to factor in order to find the length of this. So let's see, how does this factor? So what multiplies to be negative 120 that adds to be negative 2? Well, I know that 10 times 12, right, it ends in a 0. So that's usually the first one that I kind of think about. 10 times 12 is 120. But how could I end up with a negative 2 in the middle? Well, I'd need to have my 12 as negative and my 10 as positive. All right, so I have L plus 10 and L minus 12. Okay, and then set each of those equal to 0 and solve. So L plus 10 equals 0, L minus 12 equals 0. So here when I subtract this over, I get the length is negative 10 meters. Okay, now in your mind, I hope you're thinking that is not possible, right? Lengths cannot be negative. So this is called an extraneous solution. That's not really the length. So we're going to have to use this other one. So if I add 12 over, all right, let me get rid of this stuff here, otherwise it's kind of in the way. Oops, come back. Okay. So I get L equals 12 meters. All right, so that's telling me my length is 12 meters, and then my width is going to be 12 minus 2. So that's going to be 10 meters. So the width is 10 meters. And those would be my answers. Okay, now some people are like, well, why don't we just use that? Sometimes it comes out to be like the opposite of that number comes out to be the answer, but not always. So you can't just use that as it, but in this case it did. So it kind of looks that way. But okay, well, I think I'm going to stop there. Remember, you can take the exam tomorrow or Thursday. Please, make sure that you get registered for it if you haven't yet. And if you come across any questions you have, just send me a message and I will do my best to get back to you and answer those questions for you. Okay? I hope you guys have a good night. If you have any other questions, you can stay on and I can do maybe 1 or 2 more if you need.
Thank you.
You're welcome.